Hello, good afternoon, friends. This is the third training video for pressure vessel with the help of PVLite software. From last two sessions, we started the introductory details of PVLite software. Then we added one horizontal vessel. In the last lecture, we added two nozzles. Now we will going to add a saddle support in this horizontal vessel. Everyone seen the how saddle is look. So to add a saddle support in the cell of the vessel, first of all, we will going to select a saddle from this detail tab. In the detail, you can see icon of saddle is here. So just select the click one time here. Saddle tab will open. So in that saddle, where various information you need to fill, like distance from node. Here, this is the node. This is called as a node. This joint from this to shell. This is the node, and then we can add a name of saddle. Like this one is the left side, so we'll keep as it is left saddle. So distance from the node, we can add from this node. How much will be the distance of saddle? So as our vessel is of suppose it is 1500, so we will keep both saddle distance in between 100 and 1000 mm. So from here we will keep it is 250. Then saddle width, saddle width saddle width is this width. If you see here in the drawing, saddle width is this saddle width. We will keep saddle width as 150. Then tangent dimension A. Dimension A, if you see, it's from tan line dimension. So tan line dimension will be if our distance from node is 250. So tan line dimension will be tan will be 50 mm ahead of this joint. So it will be 300. We will add 300. Then center line dimension. So center line from the vessel center. So vessel ID is 1500. So 750 will be the ID. 750. We will keep it as 1100 as a center line distance. Then saddle contact angle, mostly saddle contact angle is 120, but you need to follow your data sheet or design specification. Then wear plate is the this plate which is in contact with this saddle vessel OD and this saddle support. It is a part of saddle support. It is so it will be 120, will keep as it is. Wear plate width thickness, wear plate width, this is the width. So this as saddle width is 150, we'll keep it as 250, 50 mm each side. Wear plate thickness, we can keep as it same as vessel shell thickness, 8 mm. Wear plate contact angle, mostly it is 132 degree, but again you need to follow your specification. Height of section ring, there is no this is the, if you can see in the drawing, this is the section ring. When there is a failure in the saddle, in the one of the stresses will govern, if one of the stresses is governing in the saddle in the vessel, at that time we are using this height of section ring, but in our case it will be 0. What is the friction coefficient? So in the horizontal vessel, saddles are mostly of one is the fixed saddle, other one is the sliding saddle. So if we consider the left saddle is a fixed saddle, so for the fixed saddle, coefficient of friction will be the 0. Moment factor FTR, it is by default. We can keep as it is. The E dimension, this the dimension E, which you can see here in the drawing. It's depicted from outer rib to rib outside. So dimension E, we will just assume now, for now, it may be like 1300 mm. Okay, 10 to 10 distance. So 10 to 10 distance, cylinder length is 2500. So 10 to 10 it is 2600. We'll put circumferential efficiency over the saddle and midspan 1 1. Then there is a next question is wear plate and cell material. If is it same, we will keep as it is same. This saddle is welded to cell. Yes, it is welded. This question is like sometimes the saddle is not welded, like it's just connected uh, at the material of shell here. It is 5 and 6 get 70. So saddle material we can whether we need to perform a saddle check, then click this one, and material you can select here whether it is 5 and 6 grade 70 or SA36 based on this application. Then here is the next one is the base plate length and thickness. So base plate length is the this in the drawing you can see here representation. Base plate length is this much. So I will keep same as it is 1500 ID. So here base plate will be 1450 we can keep. Saddle plate base plate thickness I will keep 20 mm. Base plate width now I am just giving by my own, but when we will make a drawing as per data sheet or actual drawing data, we can have there are various specifications also available from various company standards. We can follow that also, but now I am just giving my own based on my experience. Base plate width we can keep as 200. Number of rib for this one, it's a very small vessel, so I will keep three only. Rib thickness we can keep same as shell thickness, because most of time whenever cell material is 8 mm thickness, so we have we are just thinking about manufacturing point of view. So mostly the plates are available, so we'll try to make utilize that plate only. So 8 mm thickness. Here check outer ribs under full weight or is transverse load. This is not required because this is the in this case the whole weight is transferred to the outer rib, so there is chances of failure. And the web location, web is the center plate location where in the saddle where it is it will be if you select the center it will be in center left center like if I will show you just by clicking this one. Now this rib is in the center, if you can see it is in center. If I will make it, if it is left side, so it is side left. If I'll select, then rib will be moved to the here, web will be moved to the left. So in the by using this one now for a small size of vessel, this is most preferred design. So I will keep it as left. Then here a bolt anchor bolt calculation also we can perform by selecting this one. So in this configuration, mostly number of bolt will be 2 and number of bolt in tension will be 2. Suppose I am giving 2 bolts, 2 and edge distance, edges corrosion on 0. Bolt nominal diameter I am considering as 1 inch, and that's it. So this is the parameter we need to fill while making the saddle design. Now you can just click the OK. So your one saddle is already added to the vessel. Now the next saddle, for the next saddle, even your first saddle, you just simply add the new saddle here, add new button. You can add a new saddle. The saddle is get added. You can just rename it as right saddle, and you but from here there in the bottom there is the same as first saddle. You just click this one, same as the first saddle. So all dimension will be get copied from the first one. So you don't need to enter again and again the same data, and here just rename it right saddle. And here we'll keep all these dimensions same as that one. Just here the friction factor, first one is the fixed saddle, second one will be the sliding saddle. For sliding saddle friction factor we will consider as 4.4. uh, Mostly it is in between zero point 0.3 to zero point 0.5, so we'll just keep it as average 0.4. Distance will be same and this other dimension will be copied. We'll just click the OK, and we here we forget to change the web plate direction, so just we will select here a web location to the side right. Yeah, now you can just see here the web is located in the left, and here in the right side it is located on the right. So in this way we can add a saddle to the vessel. Now just save this one, and we can run this file. To run this one in analyze section, there is a run icon, analyze icon, or simply pressing F12 also will work. So we'll just click the run the file. Now this is the icon will this is the pop-up will come when the file is running. So now report is generated. You can see everything is okay, because if it is there is a failure, you will be get a red color. It is represented in red color, but here now it's okay. uh, this one, this color, this orange color is means this is just a simple warnings. You just need to read it and analyze it. If it is not very harmful, means it is not very if there is a concern, you can resolve that one, or you can accept that one. uh, Here in saddle, in operating case, you can check. In test case also, saddle is checked. So here there is, if you see, our wear plate width, the minimum wear plate width calculated is 271, but we provided 250. So in that case, the complete calculation, the wear plate will be ignored. So this is also one thing. So to resolve this warning, in operating case also, operating case there is no warning. Okay, but in test case there is a warning. So in order to resolve this one, what we can do here, we will just go to the next, back to again to the job, and here wear plate width we will make it 275 in the first, and in the next saddle also. By clicking the next, you can move directly 275. You just press the OK. Wear plate width will increase. Save and run again the file. Now file name, now report. You can see in test case that warning is gone. So in this way, by reading the report, you can find out what is the warning and you can remove that warning. And after giving the input, after generating the report, you need to understand how to read the report, where what are the different parameter. Like if you go in an internal pressure calculation, so how the calculation is done, in that you need to see that how, what are the element, like left dish, shell, right dish, it is here. Then liquid plus, it's a hydrostatic pressure is here, because our provided pressure may be different, but here the pressure is different, so it's hydrostatic pressure is added. Thicknesses, corrosion allowance, diameter, allowable stresses is considered. So we need to understand what exactly the software is doing. We can check the MAWP in corroded condition, MAP in the new and cold conditions. So we can identify the MAWP like 684. It is limited by right dish head. In internal pressure calculation only, we can check that MAWP here, it is governed by 684. So it is limited by right dish head. So we need to report these things in the drawing as well. And MAP we can check here just next to this one, 1286. It is limited by dish head also. And minimum thickness requirements also here, 778 required. Required thickness, minimum given thickness 778, and required thickness 5.45, 5.46. This way we can check the requirement MAWP, MAP in the report. We can also see the left descent calculation. So the left descent, the representation, minimum thickness is given 7 mm, ID is given. In this, the various inputs, corrosion allowance, here it's allowable stresses, what it's considered in calculations. These all informations are there. Then radiography requirements like 100% long seams are same. Then there is a tolerance also available. Then there is an internal pressure calculation, how its calculation done, required thickness 2.25, and corrosion allowance. With this addition of corrosion allowance, it become 5.45. So this is the minimum requirement. After that, MAWP is calculated for the dish head. Then MAP is calculated and corroded. So this report we need to check the report, and we can understand that which MDMT curve is here. We can see also MDMT curve. Here B curve is selected because our material is not normalized. We not considered. But in case if our required MDMT is in the negative side, or maybe the lower, so in that case we can need to select material as normalized, or maybe the impact tested based on that requirement to fulfill. So this is the way. I hope this is helpful. So thank you. I hope with this, uh, in the next session we will going to make actual from drawing one pivot model for the vessel. After that, maybe I will do one heat exchangers design, complete heat exchanger design. So thank you. Bye bye.